Alrighty, good morning everybody. It's Miss Clark. I'm making this video to help you with your science test today. So this is the forces cause change test. These questions will look very familiar to you, which is good, but I would like you to make sure that you are on Performance Matters and that you have opened up the forces causes change test, and the title looks like this. I'm highlighting my screen right now. Forces cause change. It should be on your Performance Matters already, and you may hit begin. We're going to take this together. So similarly to how we took the last test, how I read each question to you, we are going to take this one again. Now if I go too fast, please just have Miss Davis pause the video, and you guys can answer it however much time you need. And you can always skip a question and go back. So let's get started. Number 1. Which object needs the greatest force to put it in motion? Is it A, a bike, B, a car, C, a NASA rocket, or D, a train? Which object needs the greatest force to put it in motion? Okay, next question, number 2. It says, for a rummage sale is kind of like a garage sale. 4 students are helping to move boxes full of items on a cart. Assuming the floor is the same and that the students all with the same force whose box will travel the shortest distance in 10 seconds. So, I'm going to read that question again. Assuming the floor is the same and that the students all pull with the same force, whose box will travel the shortest distance in 10 seconds? The shortest distance. Is it A, Frank, whose box weighs 25 kilograms? Is it B, Carson's, whose box weighs 22 kilograms? Is it C, Tina, whose box weighs 20 kilograms? Or D, Nestor's, whose box weighs 15 kilograms? Whose box is going to travel the shortest distance? If we all push with the same amount of force, who's going to travel the shortest distance? Okay, next one, number 3. Josh saw a package on the table. He tried to lift it, but it did not move. What can he conclude from this? Is it A, the friction between his hands and the package is preventing him from lifting the package? B, he is applying more upward force to the package than its weight is applying downward. The package's weight and the table are applying more downward force on the package than he is applying upward, or the force of gravity acting on the object was equal to the upward force he was applying. So he tried to lift the box, but it didn't move. Why didn't the box move? Okay, number 4. 4 students moved identical carts along the floor for the same number of seconds. 2 students pushed the carts and 2 students pulled the same cart. Jasmine pushed with the smallest force. Isabel pushed with 2 times more force than Jasmine. Nick pulled with 3 times more force than Jasmine. Or Ken pushed with 5 times more force than Jasmine. Which student's cart moved the farthest? Was it Isabel, Jasmine, Ken, or Nick? Make sure you pay attention to the names because they're a little bit out of order, so make sure you select the correct name. Alrighty, moving on. Sorry, my computer froze. Oscar is experimenting with toy cars of different sizes and masses. He pushes each car with the same force for the same amount of time, then lets go. Which car travels the fastest? Sorry, my pictures are all goofy. Your pictures, look on your screen and look at the pictures. One of them is 2 kilograms, one of them is 3 kilograms, one of them is 4 kilograms, one of them is 5 kilograms. And it's asking you which car travels the fastest. So he pushes with the same force, so which travels the fastest? Guys, I'm going to change my screen really quickly. I'm going to use this one. I'm going to use this screen instead. This one's a little bit better. Okay, number 6. What happens to an object at rest if the forces applied to it are equal but act in opposite directions? What happens to an object at rest if the forces applied to it are equal but act in opposite directions? Is it A, the object will not move, B, the object will accelerate, C, the object will move at a constant speed, or D, the object will move in another direction? So what happens to the box if there are 15 newtons of force pulling to the left, 15 newtons of force pulling to the right? What will happen to the box? That's number 6. Number 7 says, 2 students push identical boxes across the floor. Amber pushed her box with twice as much force as Jaden pushed his. What happened to the boxes? So Amber pushed her box with twice as much force as Jaden. Is it A, Amber's box didn't move at all? B, Jaden's box moved faster and farther than Amber's? C, both boxes moved at the same speed and for the same distance? Or D, Amber's box moved faster and farther than Jaden's? Number 8. Henry has 2 large toy cars. His red car has a higher mass than his blue car. How can he push both of them to make them move at the same speed? So red car weighs more, blue car weighs less. How can he make them go the same speed? A, he can push both of them with the same force for the same amount of time. B, he can push with the same force, but he will have to push the blue car for a longer time. C, he can push them for the same amount of time, but he will have to push the red car with more force. Or D, he can push them for the same amount of time, but he will have to push the blue car with more force. The red car has a higher mass than the blue car. So what does he need to do? I'll give you a second to answer that one. That one's kind of tricky. Number 9. Use the diagram of the forces being applied to a book to answer the question. Which statement best describes the position of the book? So looking at that picture, which statement, oh sorry, I just read that. Looking at the picture, is it A, the book will move to the right, B, the book will not change position, C, the book will move to the left, or D, the book will fall to the ground? Based on that picture, what do you think will happen to the book? And number 10. Rick and Corey are racing side by side on identical one-speed bikes. Corey starts to apply more force to his pedals than Rick. What is most likely happening? Is it A, Corey is getting tired? B, Corey is starting to go faster than Rick? C, Corey is allowing friction to slow him down? Or D, Corey is increasing the force of gravity against his bike? So Corey is applying more force to his pedals. He's pedaling faster. What do you think is going to happen? Alrighty guys, that is the end of the test. It's just 10 questions. What I would like you to do is go back through the test on your own and check your answers before you submit. Once you are confident, submit your test, and then I would like you to be reading a book on EPIK or reading a book from my library. You still have an AR goal to meet by the end of the quarter, so make sure you get that done, okay? And make sure you're on your best behavior. I miss you guys, and I'll see you Monday. Bye!